Okay, so question 8 here asks us to write a function that decrypts what we encrypted earlier. So if you think about what we need to do with a decryption method, what we're taking in is a message and an encrypted alphabet and returning that message as run through the unencrypted alphabet, essentially. So really, if you think about it, all we're doing is the same thing we did up here, but switching the alphabets around. So if I take this down here and change this to unsubstitution with message and key, what we need to do is essentially the same thing. So we have our two alphabets here. We have our key alphabet defined up here. So if we go through each character in the message and check to see where it is on our key, we can then translate it to a new, essentially, version of itself. So because it's going to be a lot more complicated if we include uppercase characters, I'm not going to include uppercase characters in this case. I'm still going to include my check up here to see whether or not what we're including is a punctuation mark, right? So if the character isn't in this case, we don't want to check for alpha, we want to check if character isn't in key. So if the character that we're trying to translate is not in our messed up alphabet, then we just want to return that character, right? Otherwise, we need to find the key index of the current character and add the alphabetic character at char index to return string. So all we're doing is, I don't even need this, so I'll get those out. All we're doing is using key find instead of alpha find and indexing into alpha. So for example, if we go up here and we create a messed up alphabet, so let's change around a few letters. Let's change E and F. Let's change J and H we already did. Let's change L and T. Let's change W and A. And what else can we change? R will change for P. And trying to think of what else is in Hello World. D will change for G. Okay, so there we go. So if we run this now and run Hello World through it, what we'll get is a messed up version of Hello World. Okay, so there we go. If we then run our desubstitution method, so unsubstitution, and put in that message as our message and our key from up here as our key. Oops. Make sure that I actually have the right character over there. There we go. And then print that. We should just get Hello World. So let's see if it works. Save it. Run it. Nope. Why is it? Oh, because I forgot to import string. So you could do this without, and I don't actually need this. You could do this without calling the string ASCII lowercase, and so you would not have to import the string module. You could not import the string module and just have alpha be equal to A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, WXYZ. So you can do this, and you wouldn't have to import the string module. The string module has like a lot of useful things on it aside from just this, however, so it's kind of useful if you're going to be doing more than just needing the alphabet once to import the string module, but we can do it without it. So there we go. That just reverses what we did before, changes this to hello world. So really, it's just an inverse function to this up here. So all I did, aside from take out the uppercase stuff, so if I take this stuff out here, take this out here, take this out here, have these out, get rid of these, oops, get rid of these. Alright, if I take all that stuff out, you can see that all I've switched around is the words alpha and key. Where I had alpha before, I have key. Where I had key before, I have alpha. I'm just switching those two alphabets around in order to get the unencryption version.